Bueller? Is Nicole here? Apparently not. Here, wait. I have a permanent seat for you. Seat 90. Not sure what. How's that work? Okay. All right. Okay. Today, we're going to look at a third market structure, oligopoly. And as we'll see when we answer the three basic questions for today's lectures, we want to determine what are the outcomes under oligopoly. And it's going to be a lot more complicated than it was for competitive market structures, and certainly more complicated than it was for monopoly market structures. We will explain why it is difficult for oligopolists to cooperate, in large part because their self-interest is inconsistent with the collective or cooperative interest of the oligopolist. And then third, the antitrust laws that we briefly mentioned in the last lecture, they play a critical role in such oligopolistic structures, and we'll look at a few of those particular laws. And as we'll see, because if there are very few firms in the marketplace, there is strategic interactions among those firms. And the lens that economists use to evaluate those strategic interactions is game theory. And as you all know, that's a branch of mathematics, but it becomes an important lens by which to evaluate the rationality of such strategic interactions. Okay? All right. Now, how important are these market structures? They're very important when there is a high concentration of the total output that's moving through the market by a few firms. And what I'm going to do is present to you, which is not in your textbook, some leading products for which the four largest firms dominate. The higher the concentration ratio, everything else constant, it follows that there's less competition. And we'll focus then on such market structures where there's a high concentration ratio. Now, here's some examples. If we look at video games, tennis balls, for example, the four largest firms that sell tennis balls represent 100% of the total output that moves through the market. Credit cards, the four largest firms, American Express, MasterCard, Visa, they control 99% of the total output of the total services in that market. Gabe?
Was the number was four firms?
No, in terms of this illustration, I want to make it comparable from one industry to another, so I selected four.
The concentration ratio is like 10.
No. There are formal measures that are used by the Department of Justice to evaluate the degree of concentration, and they use what's referred to as a Herfindahl measure, but it's based on the largest firms and what is their control of the output moving through the market. Okay, soft drinks, 93%. We're looking at Pepsi-Cola, Coca-Cola, and a few minor players like Dr. Pepper. There's an interesting story there. When you look at antitrust and you look at soft drinks, there was a fair amount of consolidation that took place in the industry, and the defensive strategy on the part of Coca-Cola to stop Pepsi-Cola from increasing their acquisitions and their concentration and thus presumably greater market power, to get the Department of Justice to pay attention, they went out and tried to do a deal with Dr. Pepper, which would make the industry even more concentrated. Okay, but that just gives you an illustration that it is an important market structure. Okay, it's one in which there are few sellers. So there's a sharp contrast with our competitive market structure where we argue that there's many, now there's few. How few? Depends on the facts. Okay, the strategic behavior that emerges here, a firm's decision about the price or the quantity that firm offers to the market, each firm realizes they have to take into account not only what the buyer's response might be to the price they charge or the quantity they offer, but in addition, what's going to be the response of other firms they compete with. When there are many sellers, it doesn't make any sense. You don't have to worry about that, right? But if there are just a few and you make a major move, you have to recognize that your competitors will react. And if you're going to be rational and you're going to optimize or maximize your profits, you're going to have to take into account their reaction, right? And that's where the strategic behavior arises. And that's where we turn to game theory that studies or analyze how people behave in strategic situations. Okay? Let's take a concrete example. There's some city, we're going to call the city small town, and there are two cell phone providers. And as a result, we have a special case of an oligopoly, namely a duopoly, because there are only two firms, right? Okay, this is the demand schedule that exists in this small town. And what we have here is for all of the prices, we have the corresponding quantity that will be demanded by consumers in that small town. Let's assume that the small town has 140 residents. The good, what's being sold, is cell phone service with unlimited anytime minutes and a free phone. And what we have on the left here is that demand schedule. There are two firms, as I indicated, it's duopoly, and the two firms, we've got to stop and think about it for a moment. In this particular marketplace throughout the country, there are only three firms now, these two, and a third, Sprint. They are an oligopoly in this small town. And let's presume that each firm's cost structure is as follows. The fixed cost is 0, and the marginal cost is 10. Okay? And by the way, you should realize, even if I had a fixed cost different than 0, is it going to make any difference? Why not? Because fixed costs don't matter with regard to incremental decisions, right, at the margin. They don't matter. Right? Is that fair? Okay. All right. Okay. Looking at the revenues for each of the prices and quantities that are listed off the schedule, this is the computation of revenues. The cost, simply multiplying the marginal cost, is very convenient because the marginal cost is constant, so all we have to do is multiply the marginal cost times the quantity, right? And moreover, we can compute profits. So this is, the last column is the aggregate profits for both firms, right? And now the question is, how will the size of the pie be divided among the two of them? So the competitive outcome, how do we know that a quantity of 120 is a competitive outcome? Given what we've discussed in prior lectures, we know that for the competitive firm, they're going to be setting price, they're price takers, they're going to pick price and set that equal to marginal cost. Okay? And economic profit at that competitive equilibrium should be 0, right? But would we expect these two duopolists to behave by each producing, say, 60 units for a total of 120 and generating a price in the marketplace of 10? Should we expect that? first thing, just common sense. Why in the world are we distinguishing oligopoly if it's going to give us the same outcome as a competitive structure, right? Now, can we look at that schedule there and determine what is the monopoly outcome? Anybody have any thoughts about how to do that? Yes? When which? When price is 40. When price is 40. And how did you determine that the right answer is when price is 40? That is a good reason, and that is the right answer, but I was hoping for another answer. Namely, that if I look for a monopolist, remember a monopolist is following the decision rule setting their marginal revenue equal to their marginal cost. You were given what the marginal cost was, it's 10, right? So if I look across this schedule here, and I look at what is the marginal revenue, I can compute off of this revenue schedule what the marginal revenue is, right? And if I do so, I'll get the same answer you did. Namely, it's the point at which profits are maximized, and if we take the revenues at, say, the quantity of 70 and the revenues at 50, to come to what the marginal revenues for 60 is, that difference is 200, right? And the unit difference is 20. And a simple computation of marginal revenue, 200 divided by 20 is 10. And that marginal revenue has to be set equal to marginal cost. You did it a simpler way, but I'm hoping to illustrate the concepts through. Okay, so the monopoly outcome is one in which price is 40 and the total quantity moving through the market is 60 for a profit of 1,800. Okay? Now, when we stop and ask ourselves the question, how will these two duopolists behave? Will they collude and determine that their best option, if they want to jointly maximize profits, is to agree on sharing the maximum profits, which we have in the prior schedule of 1,800. So going forward, if they were colluding, they would reach some agreement about how they would share the market. And what they want to do is jointly generate that $1,800 of profits. And each of them could sit down and figure out some equitable sharing and say, gee whiz, I'll take half and you take half. Right? That seems reasonable. So it's 1,800, so each of them would generate $900 of profits, and each would produce a quantity of 30, and they both capture a price of $40. Okay? That would be the outcome for collusion. Now let's analyze whether it's in their unilateral self-interest to abide by that agreement. In other words, is there some incentive for them to defect from that agreement? Right? That's what we're going to do in the next chart. Okay? And this is going to be an active learning example. Suppose the initial conditions are they've reached an agreement, they're going to jointly share the maximum profits, which is going to give them 50%, each 50%, $900 worth of profits. And if T-Mobile reneges on the agreement, what happens to the market price? What happens to T-Mobile's profits? Is it in T-Mobile's interest, its self-interest, to defect or renege on the agreement? And if both firms renege and produce a quantity of 40, determine each firm's profits. Visit with your neighbors. Give me the answer. Then Q is 60. Okay. All right. Okay, let's have an answer. Cameron, you got an answer? Yeah. Right. Go ahead.
So if T-Mobile's not considering any of the other, so I guess I want to see kind of like on the strategy, if they're not considering any of the other firms, then they would release on the agreement, but in reality they should not, because in the end it will get less profit. So.
Right. In the end, it will get less profit. Cameron's dead right. If they both stick to the agreement, they're going to be better off. They're each going to generate profits of 900. But when T-Mobile, once they've reached that agreement, then is the agreement sustainable? Will it last? And if T-Mobile reneges and produces 40, not 30 units, the market quantity will turn out, now the total will be the 30 from the other duopolist, 40 from T-Mobile, and when I take that 70 and come over to my schedule here, the 70 will generate a price in the marketplace of $35, right? And as a result, T-Mobile will benefit by that move, right? It will now generate $1,000 of profits, not 900. But T-Mobile doesn't conduct itself in this market without taking into account what its other duopolist is going to do, namely what will Horizon do. And in T-Mobile's own self-interest, they would be delighted if they could increase their quantity to 40, right? But now, what about Horizon? Horizon goes through that same thought process and looks at whether it would be better off by reneging. And it will find the same answer that T-Mobile found, and as a result, you'll end up with a market quantity of 80 and a price of 30. Okay? And that, of course, assumes they can't hold to the agreement, and now each firm will be worse off than they would be if they could abide by the agreement. each of them now will be generating $800 of profits, not the $900 that they would under the agreement that existed with respect to collusion. Okay? Collusion versus self-interest. I've already noted this. Both would be better off if they stuck to the cartel agreement. However, each firm has a private unilateral interest or incentive to renege on the agreement. And as a result, it is generally very difficult for oligopolistic firms to form a cartel and honor their agreements. Right? All right. Let's take a second example and look at the oligopolistic equilibrium. And here is the specification. Each firm produces a quantity of 40. Now we ask ourselves the question, would that be an equilibrium? Would it now be in each of the two duopolists unilateral self-interest to increase once again from an output of 40, say, to a higher number, 50? Is it in Horizon and T-Mobile's interest to make that next move? Okay, visit with your friends and tell me whether or not they will have an incentive to increase from 40 to 50. And if they don't have that incentive, then the 40 output for each of the two duopolists is, in fact, an oligopolistic equilibrium. Right? Okay, go ahead. So, let's see if we can get an answer. Eric, what's the answer? Say what? But is it in their incentive to increase? So there's no unilateral self-interest for either T-Mobile or Horizon to move from 40 to 50. Right, and the reason is? That's the right answer, but the reason is? I think you started to explain it before I deterred you from. Because we're going to be, if they both increase, we're going to be at a price of 20, right? Pardon? It's time to get some glasses there. You can't see that far. Are you serious? Okay, fair enough. I'll help you. It turns out that if they both go to 50, the aggregate quantity that's going to move through the market is going to be 100, and the price is going to be 20. Do it, fine. I prefer you to do it for one of them. So T-Mobile increases from 40 to 50. Now, the total amount, if Horizon does nothing, right? Right, exactly. So we're at 90 now, and the price is now 25. Go ahead. So there would be no incentive for them to move away, right? Okay, that's the right answer. Thank you. Okay, this is the answer. If each firm produces 40, their profits are 800, which we've already noted. If T-Mobile increases its output to 50, the new market quantity, assuming that Horizon does nothing, right? The new market quantity is going to be 90, the price is going to be 25, as Eric pointed out, and as a result, its profits is going to be 750. Hence, it has no incentive to move away from a quantity being offered to the market of 40. Likewise, if we do the same analysis for T-Mobile, we're going to get the same answer. And as a result, the equilibrium is 40-40, right, with regard to quantity output. Okay. Look, I'm sorry, yes? How come? Because of what happens to prices as reflected on this demand schedule. Because each of those two duopolists are interacting with one another, but they're interacting under the market conditions of this is the willingness to pay on the part of the residents of small town. And that is reflected in the schedule here. Yeah, certainly. It depends on the facts with regard to demand. You can't determine the optimal actions or interactions without knowing what the market demand is. Okay? All right. Let's turn to game theory. Game theory is a lens, as I suggested, that helps us understand how the firms will interact with one another. And in game theory, as in a chess game or checkers or whatever, each of the firms are referred to as players. Players can be any agents in the economy. And one of the critical concepts that comes out of this theoretical lens is what's noted as dominant strategy. And it turns out that those words were already spoken in lecture today. But it's a strategy that is best for the player, regardless of the strategies chosen by the other players. So some games have dominant strategies and some games don't. Right? We're going to look at a number of games where there is a dominant strategy, and thus each firm or each player will choose that dominant strategy regardless of what other firms or other players might do. Now, one major game is Prisoner's Dilemma. It's a game that was first introduced when, in the context of two captured criminals who have worked together to steal, bank robbers, whatever, and how one would recognize the dilemma that two